I've been working on a deck and framing out a second-story cabin on the top of my shipping container, and the time has come to replace this old rickety barn ladder that I've been using with something a little bit more substantial. So in this video, I'll show you how I built this steel staircase on the side of my container. This video is broken into 7 parts, which are time-stamped in the description below. Step 1 is figuring out the type of steel that gets used, and a quick search of the internet tells me all kinds of steel get used. But the type of steel I came across the most was the C-Purlin. This is normally used for wall, roof, and flooring framing in metal buildings. But I see it a lot in staircases too out here, particularly some that I found on my property when I bought it. Here's a 2-stepper that's framed with C-Purlin. You can notice the C is actually facing out. The steps on this are what are called Z-Purlin. Comes down in the front and up in the back in the shape of a Z. Here's a 3-stepper made out of C-Purlin. On this one, the C is facing in, and the stairs, also made of C-channel, sit inside that groove. I thought these looked pretty good, pretty industrial, so I figured I'd give the old C-Purlin a try. So what I'm using is 8-inch, 14-gauge C-Purlin. I've seen container homes with the staircases on the front, on the back, and then rarely on the side. I had always planned to put this staircase on the side. Then I ended up building a deck in front of the container. So I've got to make this thing fit without going past the front of the container. The big question I had was, should I build a landing at the top of the staircase? It makes sense, but you don't have a lot of space. If I wanted to build a landing on the side of the container, I'd need to have a very steep angle like I've got here. Just eyeballing that, I know that ain't gonna work. It's just too steep. The other thing I could do is go up and extend the landing out past the container. But that seems a little bit odd. You walk up the stairs, you go past the deck, and then you have to come back onto it. That doesn't make a lot of sense either. So, no landing. I knew it would be okay. Here's a picture of one by Bob's Containers without a landing, and I think it looks fine. After some quick measurements to figure out how long my stringer needed to be, this is the old A squared plus B squared equals C squared. I was able to set my C-Purlin up there and mark it so I could cut it square with the top of the deck. Metal cutoff disc on the angle grinder is the tool of choice for cutting the C-Purlin, or at least the tool I had available. When I grind the paint off, clamp the C-Purlin up to the side of the container, and I can go ahead and tack weld it in place. Notice that I went with the C facing out. I figure it would be easier to put stairs on the smooth interior of the purlin. To set the other stringer in place, I need to know how wide each stair is going to be. It seems like the standard is about 3 feet, but I think I can get away with a little bit less than that. I've got a tight space between my camper and my container. I just want it to be big enough that I can bring a wheelbarrow through there. Not sure how wheelbarrow width became the standard, but it's what I went with. So I settle on 30 inches, 2.5 feet. I then cut 2 30-inch pieces of scrap square tubing and weld them to the C-Purlin that I've got in place. They're just tack welded so that I can get them nice and level and flush with the edge of the container. The more metalwork I do, the more of a benefit I find to doing work that isn't actually supposed to be part of the final product. So I don't need these square tubes to be part of the staircase, but they're holding it together initially. Same deal with a wood brace that I make to hold up the second stringer. With the other stringer braced, I can go ahead and tack it in place to the square tubing, both at the top and the bottom. It doesn't come out perfectly, so I've got to play around with it a little bit and get it re-leveled. Now I'll go ahead and cut and install those 30-inch stair treads. As with the stringers, I'm just tack welding everything. I won't do full welds until the whole staircase is put together. I've started the first stair a logical distance up from the deck, figuring I'll come off the deck a lot onto the staircase. I'll go back later and weld the stair underneath it. The C-Purlin is bowing out and not sitting flush against the stairs, so I weld a piece of angle iron onto the stair tread, and then I can use a clamp to tighten the purlin up against the stairs. I figure out the distance between steps by tack welding another step up there at a logical height, and then just kind of playing around with it. Too close and your feet get tangled up. Too far and your quads and hammies are on fire going up the stairs. I ended up doing 8 inches from the top of one tread to the top of the next. The front of the stair sits flush with the stringer, at least ideally. The name of the game here is to cut each step so it sits tightly in between the stringers. Then bring up the level, bring up the hammer or the fist, and get this thing level front to back and side to side. These C-purlins want to fight you a little bit. They don't just slide in perfectly. In learning welding, I thought of the tack weld as being something that holds the metal in place until you do a full weld. It is that, of course, but I also am now beginning to think of it in terms of being just a very temporary weld that can easily be broken off so that you can move the piece as needed. One thing about welding is that the heat of the weld might bend the metal in a part that you're not working on. So constant checking, re-leveling, and not welding for too long in the same place may be the name of the game. Once I get to the top of the stairs, I just cut the stringers flat so they'll sit flush with the very top stair. And I weld that last stair into place. Cut a piece of plate steel and weld that to the back of the stair. And then little pieces to cover up the gap in the C-purlin at the top. When it comes to welding to the side of the container, the corner casting and the corner post stick out farther than everything else on the side of the container. So you can weld to the post, you can weld to the casting, but you would need a metal shim to weld to anything else on the side of the container. As I mentioned, I welded the top of the C-purlin to the side of the top corner casting. I also put a galvanized carriage bolt into the deck through the C-purlin. And at the bottom, I welded the C-purlin to the door hinge on the corner post. On the stringer that's not on the container, I dug a hole and poured a footing, locking that piece in concrete. And then on the other side, I took a 2x2 piece of square tubing and made a vertical support, which I welded to the underside of the staircase and then buried in a concrete footing as well. With the stairs in place, I'll make a handrail out of 2x2 square tubing. An internet calculator tells me that the angle of my staircase is 49 degrees. So I use that information to start making a handrail that is plumb to the ground. I don't trust that internet math. So what I do is I use 2x4s to check the angle. A miter saw only cuts a 45-degree angle, but you can get more than a 45 by taking a 2x4 that's cut at 45 degrees, clamping it in place, and then adjusting the miter saw by whatever additional degrees are needed. I've got this one set 3 or 4 degrees off of 0, so I'm going for a cut of 48 or 49 degrees to see if that's correct. Wood's cheaper and easier to cut than metal. This is just a good way to check the math. I take that 2x4 over to the staircase. The angle looks good. I can find the height, which is going to be about 3 feet up. And then I'm ready to cut the metal. Unfortunately, that same hack doesn't work on my metal chop saw because that guard blocks you from getting a piece in there. If there is a hack for cutting it more than a 45 on a metal chop saw, I don't know about it. And so I'll use the 2x4 as a guide to mark the cuts I need, and then back to the old angle grinder. That same 49-degree cut gets made on both sides of the square tubing. Now I can get that piece tacked into place. The most difficult cuts for me were these intermediate handrail pieces. And again, back to the scrap 2x4 to figure out the distance and the angles. I'm constantly being reminded what a valuable friend the old clamp is. And I'm able to use it here to hold the tape measure so I can get a good measurement on this intermediate angle piece. On the back I add another vertical and then a horizontal across the back onto the deck. And I'll include this in a future video about the deck. If you hear a real welder talk about their welding, they'll go, oh yeah, I can make metal stick together, in some sort of effort at humility, all the while laying down perfect welds. I can make no such claim to perfect welds. I can make a claim to being able to get metal to stick together. So be easy on me here if you would like to comment on the welds. Another thing that you'll hear welders say is grind and paint make the welds that ain't, and so that's my general operating philosophy at this point in time. The paint is the same exterior stain enamel that I use for the shipping container, which I really like. And then luckily I remembered at the last minute that I need some aggregate so that the treads aren't slippery, and I added this Homex Tread Tex, which worked out nicely. That's my container staircase. A little preview of what I've got coming your way. I mentioned that I'm working on a deck on top of the container. I'll finish that up and put a video out about it. And then I'm framing up a second story cabin up on top of the container, and I'll put a video out on that. And lastly, I'm still working on the interior of the container, which will be part 2 of my original shipping container video. If those videos sound interesting, be loose with the old finger on the subscribe button so you can pick up those videos when they come out. Take care.